Alright, now in this question here we need to figure out how many molecules are present in 13 grams of sodium carbonate. Now in order to figure out the number of molecules we need to know the number of moles. However, they do not give us the number of moles in this question. So whatever are we to do? Well, they give us the mass in this question, which is 13.0 grams, and anytime they give us the mass we need to know the molar mass. And if we know the mass and the molar mass, then we can figure out the number of moles, which allows us to answer this question. Now remember, if we're going to calculate the number of moles, we are going to have to divide by the molar mass. So I take the mass and I divide it by the molar mass. So now I end up with 0.12265 and a few more decimal places moles, and I'm going to need all of those digits when I do my next calculation, and it turns out that I'm going to need a little bit of space. So I'm just going to shrink this up and put that right over there and give me a little bit of room to calculate my number of moles. So my number of moles is going to equal 0.12265 plus a few more decimal places. I'm going to multiply that by Avogadro's number, and I'm going to get 7.39 times 10 to the 22 molecules. In question number 8, I need to calculate the mass of 3.50 times 10 to the 25 molecules. However, I don't have the number of moles, and I always need to know the number of moles in order to figure out my mass. So that means I need to figure out my number of moles in another way. Fortunately, I know Avogadro's number, 6.022 times 10 to the 23 molecules per mole, and I know the number of molecules is 3.5 times 10 to the 25. That's definitely more than 1 mole, but I can figure out exactly what that is. So of course, to find the number of moles, I'm going to do division, and I end up with 58.1202 moles. And of course, because I'm doing this on a tiny little iPad, I need to shrink up a little bit so that I can have some space. I'm going to take this, I'm going to shrink you up over there. I'm going to take this calculation, oops, I'm going to take this calculation, I'm going to shrink you up over here, and then finally I'm going to take my 44.01 grams per mole, and I'm going to multiply it by my 58.1202 moles, keeping a few extra significant digits, and I end up with 2,558 grams. Now I don't have enough significant digits to carry that through, so that's going to be 2.56 times 10 to the 3 grams. Okay, in this question, we're asked to calculate the volume of a gas. In order to calculate the volume of a gas, we need to know the molar volume of the gas, and we also need to know the number of moles. But they don't give us the number of moles in this question. However, they do give us the number of molecules, and we know Avogadro's number from our periodic table. This allows us to calculate the number of moles, which we can then use in our calculation to figure out the volume. And so we jump ahead and we have that many molecules divided by that many molecules per mole, which gives us 2.773165 times 10 to the minus 4 moles. And again, I'm going to have to use this number in a calculation again, so that's why I ended up using more significant digits than I need. So to figure out my volume, I'm going to take the 2.77 times 10 to the minus 4 moles, and I'm going to multiply it by 22.4 liters for each and every mole. And my answer is going to work out to be 6.21 times 10 to the minus 3 liters.